As long as humans have existed, we have searched for ways to understand the world around us. Cave paintings, maps, even fine art, all are different interpretations of the visual world, and they all tell us something about our ancestors, our brains, and ourselves. As we approach a new age of artificial intelligence and robotics, we face an even greater challenge. Not only to understand the world ourselves, but to teach the machines we build to understand it as well. My name is Charlie Houseago. I'm a researcher here at Imperial College London, and today I'm going to show you one of the most powerful tools in computer vision we have available, the convolutional filter. So, the idea of a filter is already something you're familiar with, even though you don't know it yet. Every time you ask the DJ to crank up the bass, you're using your knowledge of what a filter does, make some parts of a signal stronger. So just as I can use this amp to control whether I get more treble, or bass, computer vision engineers can use filters to pick out some parts of an image. This is what a filter looks like for an image. Lay this window over every pixel in the image, and where it's white, we add up the pixels, and where it's black, we subtract them. So if the image is the same on the two sides, we get a small signal, and if it's different, we get a big one. Take two of these filters, layer them on top of each other, and you pick out all the edges in the image. These kind of simple filters have been around for ages, but back in 1980, a scientist called Kunihiko Fukushima, inspired by research into vision in the human brain, had the idea to stack many layers of these filters together and allow his computer to design them itself. He called his system the neocognitron. Fukushima used his system to recognize written characters, but with the more powerful computers we have today, we can build AI that are very sensitive to complex patterns. And I'd like to show you what some of these look like by taking this robot for a walk. Filters in convolutional networks are quite different from the simple filters I showed you earlier. Rather than designing the filters ourselves by hand, we allow an AI to learn what it needs to understand the image itself, and the network stacks hundreds of these filters together to do just that. So, if you could look through the camera on the robot, this is what you would see. Just a color video like you would shoot on your mobile phone. But look what happens when we run the same footage through 4 layers of filters in a convolutional neural network. Much like the output from the 2 simple filters earlier, after 4 layers in the network, the filters have picked out the edges between different regions. As we look deeper into the network, though, the behavior becomes quite different. This footage shows the response in the middle of the network. Now it seems to be concentrating on more local parts of the image. The people playing football and the boundary between the trees and the sky, rather than just picking out all the edges in general. And by the final layer, the robot's response becomes even more focused and seems to be sensitive to some very specific things in the image. For example, these people walking along the path. One of the most remarkable and mysterious things is that I can't tell you for certain what each filter is looking for. Convolutional neural networks are one of the most powerful tools that scientists and engineers have available, and even though we made them, we don't fully understand them.